Today's lesson is on factoring special cases. We've been talking about special cases kind of along the way, and a lot of what we do with special cases, you don't really have to memorize a special rule for. The only thing about the special rules is they make things a little bit faster sometimes, and that just saves you some time on tests and things like that. So we will go over those special cases rules in this video so that you know them and you're able to use them when you need them. But I really don't think you have to really use them almost any time. Okay, the first concept that we're going to talk about is when you have a perfect square trinomial. In this case, we are multiplying. So in other words, we're starting out with a binomial, and it is squared. Well, squared means anything times itself. So if it says x plus 5 quantity squared, what that really means is x plus 5 times x plus 5. And again, there doesn't have to be a special rule to it. You can just go through and do it the way that we've been doing it. Just double distribute it. And so you get x squared plus 5x plus 5x plus 25. Now, of course, we need to go one more step and go ahead and simplify that. And so we get x squared plus 10x plus 25. There is nothing wrong with what we just did. It is completely mathematically accurate, and you can do it that way. However, if you are the person who likes to memorize rules and shortcuts and things like that, that's what we have up here. So if you look up here, I have the rules written out. X plus b, quantity squared, is equal to a squared plus 2ab plus b squared. Well, what does that mean? Let's look at the example we just did. What that means is you take the first term and you square it. That's x squared. That's going to go in my first spot. I'm going to go to the last spot. The last spot is taking the b squared. That is 5 squared. That's 25. That goes there. The one that people forget about is the middle term, and let's talk about how we can get that middle term. The middle term is 2ab. Okay, well in this example, a is 1x and b is 5. So if we're going to think about 2ab, that's going to be 2 times x times 5. Well, 2 times x times 5, that's 10x. So 10x goes in the middle. Again, I think that on that one, there's not much advantage to memorizing the rule, but it might be useful later. So I would just want to go through some examples of it. Let's take a look at the next one, which is example C, but we'll go down here in just a second. So we'll just go ahead and do C. So again, we could just multiply it out, which we all know how to do, but let's try to do it with the rule instead. What the rule says is you take the first term and you square it. So that's x squared. Then you go to the last term and you square it. Notice that these are both pluses. The only thing that has a minus in it would be the middle term. So that's still a plus. The middle term is the 2ab. Well, a is x, b is negative 4. So 2ab is 2 times x times negative 4, which is negative 8x. So that's that minus sign and that negative sign, they mean the same thing. Okay, so if there's a minus in here, just make sure that that term is a minus. So we just did this problem by memorizing the rule. X squared, 4 squared, and in the middle, 2 times a times b. 2 times 4 times x is negative 8x. We could have done the same thing by just multiplying it out, and we would have gotten the same answer. We get x squared minus 4x minus 4x, that's minus 8x. Negative 4 times negative 4 is 16. Let's look at some examples that have coefficients on them. So they're a little bit more complex, not too much, but a little bit. Once again, let's just start off by double distributing and see what we get when we double distribute. So when we first go through and double distribute, we get 9x squared plus 21x plus 21x plus 49. And if we simplify that, we get 9x squared plus 42x plus 49. If we did it by the rule instead of by just multiplying it, if we did this by the rule, let's take a look. A would be 3x. B would be 7. The rule says a squared plus 2ab plus b squared. So a squared is 3x. 3x squared is 9x squared. I'm going to skip to the end because I think that's easier. And 7 squared is 49. And the middle term is 2 times a times b. So that's 2 times 3x times 7. Well, 2 times 3 is 6. 6 times 7 is 42. So that means there is a 42x in the middle. Notice that's the exact same thing I have written over here. So you can do it by the old-fashioned way, which you don't have to memorize anything new, or you can try this new way, but it does require some memorization. Okay, once again, let's try this one by the rule instead of by double distributing. By the rule, I would square this. If I square that, that's a 25x squared. I'm going to square this and put it on the end. That's a 36. My last number is always plus. This time this minus, though, says that I'm going to have a minus in here. And what goes in there is 2 times 5 times 6, or 2 times 5x times 6. So that should be negative 60, because 2 times 5 is 10, and 10 times 6 is 60, with a minus in the middle. So that's what it should be. Again, you could FOIL it, double distribute it, and see what you get. You're going to get 25x minus 30x minus 30x, that adds to negative 60x, and plus 36, same thing. So again, just two different ways of doing it. I'm trying to give you a variety of tools so that you can choose which way you want to do it when you come across a certain problem. Okay, all along I've been trying to say that factoring and distributing are opposites of each other. So we just did 4 examples with distributing. Let's see if we're able to go the other way and factor those. I have the rules here. They're the same rules that are written up above. I just wrote them in here in the margin so we can see them and we don't have to keep scrolling back and forth. To do this, what we have to do is we have to kind of think backwards, because factoring is opposite of distributing. So in other words, we have to think of what's the square root of a squared and what's the square root of b squared. And that is how we're going to get our answer. So in other words, if I look at this, the square root of x squared is just x. The square root of 9 is just 3. And I'm done. And you might say, hang on a second, what happened to the 6x? Well, let's investigate what happened to that 6x. So to investigate that, I'm going to multiply this out. So I'm going to get x squared plus 3x plus 3x plus 9. Well, guess what? Those two middle terms added together, they become 6x. When you say what happened to that middle term, that 6x disappeared, it didn't actually disappear. When you have that square on there, it means that it is going to show up again if you multiply it out. And so this is the correct factorization. Now I've been trying to show you that you don't have to do it that way. You can do it the old-fashioned way. So maybe let's look at example F and see what the old-fashioned way would be. Well, the old-fashioned way on F would be to think of the factors of 36 that add up to negative 12. Well, negative 6 times negative 6 adds up to that. So I could write this as x minus 6, which of course is x minus 6 quantity squared. Same result, just different method. Let's take a look at G and H, which are a little bit more complex because they have that leading coefficient. So if we look at G, maybe we can do it with the AC method first. Let's look at G, and on G we find that AC is 36, positive 36. We want to find out it adds up to 12. Okay, 6 times 6. I'm doing this the AC method, a little bit longer. 4x squared plus 6x plus 6x plus 9. All right, I'm going to factor now. So I'm going to factor out my 2x here, factor out a 3 of here, and I'm left with 2x plus 3 and 2x plus 3, which is, of course, 2x plus 3 quantity squared. Now, could I have done that by the rule instead? Yes, I could have. Let's look at example H and figure out how to do this with the rule instead of kind of the long AC way. The rule says take the square root of 16x squared, take the square root of 25. Notice it is a minus, so I'm going to put a minus in here. Wait a second, what happened to my 40? Well, if you double check it, you can see what happened to your 40. So if we double check it, we get 16x squared minus 20x minus 20x, and a minus 20 and a minus 20 gives us a negative 40, so that is correct. Now, I will take this opportunity to say it is important to check that middle term, that C term, because if it is that C term, it has to be 2AB. If it's not 2AB, this doesn't work. Okay, you say, what's 2AB? Well, on letter G, it would be 2 times 2 times 3. Okay, so let's think about that for a second. 2 times 2 times 3, that's 4 times 3, that is 12. That's 12. That's okay. On this example, 2AB would be 2 times 4 times 5, and that is 8 times 5, and that is 40, which is here. Of course, I maybe should keep my negative, so if I had a negative 5 in there, that would give me a negative 40, and that does work out as well. So that middle term does have to be 2AB. I will say I don't try to throw in trick problems, but sometimes tests have tricky problems on them that you just have to make sure that the 2AB actually works. So those first two concepts were dealing with trinomials. Our answers in this first set were trinomials. Our questions in the second set were trinomials. This next set is actually not trinomials. We've got an answer which is a binomial, and so it's shorter. Once again, we can do it the long way or the old-fashioned way, whatever you want to call it, and we could just multiply all this out and see what we get. And when we do that, the middle two terms drop off, and so we're just left with 3x squared minus 36, and that's the answer. So the rule says you don't have to go through all that. The rule says if this is the same exact numbers, but the first one is plus and the second one is minus, you understand those drop off, and so you just have a binomial as an answer. Let's look at option B with that rule in mind. So what this is saying is I just need to square these. I get 4x squared. A minus 8, a plus 8, it's going to drop off. 8 times 8 is 64. And that's the answer. That's all you have to do. The rules just make little shortcuts, that's all. The next section is just going the other way, and we've talked about this type in class quite a bit. The way in class we've been talking about it is if we put a 0x in there, what are the factors of negative 81 that add up to 0? Well, negative 9 and positive 9. What we know is the answer is going to be x minus 9 and x plus 9, and that's the answer. When you have larger coefficients on there, you have to think about what you're doing, but it's really not too hard. What we're doing is we're taking the square root and the square root. So it's 5x minus 7 and 5x plus 7. And that's the answer. So to compare from up above, these were a trinomial and they came up with just a binomial squared. These start off with a binomial and they came up with two binomials times each other, but one's minus and one's plus. Okay, that is all we have for this lesson. Again, just to emphasize, these are rules I personally don't think you need to memorize, because if you know the AC method and you know how to factor and you know how to multiply and double distribute, you really can get by without these rules. Sometimes they are helpful as kind of quick little reminders that help you save some time, but other than that, I don't think at this point that these are necessary. Now, we will run into some later in the year that are cubic that you do have to memorize because they don't really make sense. But these, I think, make perfect sense and you don't have to worry about memorizing them. In the summary, take some time to write some things there that you would want to remember in your summary.